Hi guys, and welcome to another video here in the Year 8 series on the surface area of a prism. Yes, what is a prism? It is a fabulous shape that I'm going to get onto more. My name's Darren Masqueroo and it is really good to see you. If you haven't already done so, can you subscribe to my YouTube channel? Never going to be rich and certainly never going to be famous, but it just lets me know that you are watching. Nothing more, nothing less. Won't spam you, promise. What else? maffsguru.com. Yeah, that's my website where, again, completely free to sign up. Get over there. It's got the videos ordered by textbook, by chapter, downloadable notes, and hopefully exam questions and all sorts of stuff for you as well. Will I see you there? Hopefully. So what are we doing today? Our learning objectives. By the end of this, we'll know what surface area is, what a net is, what a prism is, and how to find the surface area of prisms. That's obviously why you are watching. Now again, it's building on all of the videos that are in the Year 8 series on this particular model of work. Okay, so using units of measurement, basically. Length and perimeter, circumference of circles, area of basic shapes. Now, this is going to build on that video relating to area of basic shapes. Yeah, areas of kites, rhombuses and trapeziums have already been done. These are fabulous shapes, and probably we're going to use the more complicated ones in exams to try and trick you, but you're not going to be tricked because you've got my help. Now, what is a prism? These are an example of prisms, and when I looked it up according to Wikipedia, what did I see? In geometry, a prism is a polyhedron comprising of n-sided polygon base, a second base, yeah, a lot of words. Now obviously this is written for about, none% of the population. Yeah, probably written by a mathematician who thought that that was clever. Me? Let's have a look at some prisms, and I've got an example of what I think a prism is. Yeah, so there are some prisms. This one here reminds me of a Toblerone packet. That one there reminds me of nothing. That reminds me of, a cube, so a dice. And this reminds me of any slab of chocolate in the world. Yes, notice how hungry I am at this moment in time. That could be a sugar cube as well. Now, they're examples of prisms, and this is how I think of a prism. When I used to work at a supermarket back in the United Kingdom, they had these amazing thing called bread slicing machines. They are violent, yes? If ever there was a time you were going to do away with somebody, that would be no, I wouldn't. It'd be, anyway. The great thing about bread slicing machines is they put that loaf of bread in, they vibrate it, or they bounce it up and down a little bit, and I don't know why I'm bouncing because it sounds a bit stupid, and the bread sort of slices through. Now, when we get that bread back, on the whole, every single one of those slices is the same size. That's the whole point of a prism. In fact, a loaf of bread, if it was perfectly sort of cuboid, would be a prism. And that's my definition here. Can I put this shape into a bread slicing machine such that all of the sections would come out and look exactly the same? Well, yes, if I slice it this way, it's all going to end up looking like a Toblerone. And so that actually makes some sense to me. Yes, if I actually was to slice it this way, then no, all of my slices are going to come out looking different ways. So long as you can put that shape in one way, such that all of the pieces will come out, then is this a prism? Yeah, because I can put that into the bread slicing machine, and if it slices it along this section here, as in I put it front on that way, then it will end up being a prism. Another way to think about it is the front face and the back face exactly the same size, as in exactly the same shape and size, and are they connected by parallel lines? Now, all of these three lines here are in fact parallel. Yes, they will never ever meet. They'll go on to infinity and beyond. Likewise, is this one here, does the front face and back face look exactly the same? Oh, you should think so. And so there we go. Are all of these lines connecting the front face and the back face parallel? Yes, because they'll go on to infinity and beyond. Now, one of the important things you need to know is about Annette. And it's a really cheesy joke. Who is that? That's Annette Hamilton. Never met her. No idea. Once again, did a Wikipedia dad joke. Mathematical nets are what you need to know about, and this, ladies and gentlemen, is what a net is. If you take a cornflake packet or a cereal packet, or in my case, rice bubbles, or in the United Kingdom, Rice Krispies, I know, Victoria and Australia neighbour things, strange things. Anyway, if I was to take that packet and slice it down and lie it out flat so that it was still created a box, then this is effectively what I would have. So if I actually have an example here of a cube, yeah, if we actually go backwards and open it up, then the net of a cube is shown just here. Why? Because I can take this shape and turn it back into my cube. Now, yes, we need flaps and stuff. One of the things was when I was back in the United Kingdom as a form tutor, I used to, in maths, get them to make their own little nets, their own little cubes, and then I'd fill them with chocolates. Gone are those days, sadly. No longer do I fill stuff with chocolates, but I can dream that one day I'll do it again. So nets are really, really important, but why? Well, it can help me find the surface area of a prism. Now, the wording in this situation helps us. Surface, area, prism. So we are trying to find the area of all of the surfaces of a prism. And if we remember and we take that back, then we get the idea of 1, 2, 3. So if I was to draw the net of that solid, then I would be looking for the area of this square, plus the area of that 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 square. Now, obviously, outside faces only. Yeah. Now, drawing nets of these things isn't necessarily the most helpful thing. There are other ways of thinking about it, particularly for prisms. If I know that this front shape here and the back shape there are the same, then I can find the area of the front and just double it, because I know the area of the front and the area of the back are the same. So I can work out the area of the front, times it by 2, I've got the front and the back. What about the top and the bottom? What about the area of the top and the bottom? Well, again, if I look at the area of this top section and I look at the area of this bottom section, then what do we know? They are the same, yeah, because it's a prism. And likewise, if I look at the area of each of the sides, then we can see the area of this side and the area of this side is also the same. Yay, how exciting. So I can halve my work for this particular shape. And what about this triangular one, this Toblerone packet? Well, slightly more complicated because the front and the back are definitely the same. So I can find the area of the front, and once I've done that, I can find the area of the back by doubling it. But the other faces aren't necessarily going to be the same. So there I would have to find the area of that face. Then I would have to find the area of the base. And then I would have to find the area of the other side, the outer side there, and add them together. So realistically speaking, people think this is fairly tedious, and I can see why they think it's tedious, because it's repetitive. But we can do this. It just requires a calculation, and you've already done the basic areas in a previous video on mathsguru.com or YouTube that you can load up. So let's have a look at a worked example. Find the surface area of this prism. Okay, so the first thing I always do is I always work out the area of the front, because it helps me find the area of the back. So if I go area of the front, it's a triangle. So I know the area of a triangle is a half times the base, which is 6, times the height, which is 8. Now, a half of 6 is 3. And 3 times 8 is 24, and I'm going to write my units as 24 centimeters squared. So I now know the area of the front and the area of the back are the same. So I'm going to say area of front is equal to 24, and the area of the back is also equal to 24. So having done that, I'm now going to look at the area. Let's do the area of this base bit. What are the dimensions of my base? Well, firstly, the shape is a rectangle. So the area of my base is a rectangle, and we know the base of that is 6 times 15, which is 90 centimeters and squared. All right, so the area of the base, let's do that, is equal to 90. So that's the base done. What about the next one? Well, how many sides do we have left? Let's do the area of this slanted section here, this huge slanted section, and that's why they've given you the 10 centimeters there. Not to try and trick you, but to help you. So let's do the area of, I don't know what you call that, slanted section, who knows? Yeah, you can call it whatever you like, is equal to 10 times 15, which is 150 centimeters squared. So the area of slanted section is 150. And then we only have one area left to do, which is basically the area of this back section here, which is 8 centimeters high by 15 centimeters. So the area of the back is 8 times 15, which is 120 centimeters squared. How did I do that? 15 times 15 is, 15 times 2 is 30. 30 plus 30 is 60. 60 times 60 is 120. Yeah, so that's just the way I do it. So there we got the area of the back is equal to 120. So therefore, total surface area is equal to, and we just add all those together. So 150, 240, 340, 360. So let's just do a calculation up here. 360 plus 48 gives me 408. So 408 centimeters and squared. Ka-ching! And here is another example. Again, it seems to be that I'm just doing the triangular one. It's the same idea all the way through. Yes, this situation, they're trying to trick you. How? Well, we know that the side length of here and here are the same, which just so happen to be 5 centimeters. That's one of the things I'm looking for, but the same idea. Let's find the area of that front face. So we know the area of a triangle is a half base times height. What's our base length? It is 6. What's our height? It is 4. How do we know it's 4? Because we're actually telling me that dotted line through the center is giving me my height. Half of 6 is 3. 3 times 4 is 12. And again, 12 centimeters squared. So I'm going to write my surface area is equal to 12 plus 12. Why is it 12 plus 12? Because the front and the back are going to be exactly the same. Whoop, whoop. Yep, that's good. So now I'm going to rub out my construction lines. Let's do the area of the base. So the area of the base is 6 times 10, which is 60 centimeters squared. All right, so 6 times 10, so I'm going to do plus 60 for my base. What about my slant side here? Well, that's my slant side here. We know that's 10 times 5. So the area of my slant is 10 times 5, which is 50 centimeters squared. So we're going to add on 50 there. And then what about this other slanted side? Well, the good news is that we know that this length here is also 5, and that length there is 10. So I'm just going to add on another 50. Do my calculations, and I'm going to say, therefore, total surface area is equal to 100, 160, 72, 84. 184 centimeters squared. Let's just check that. 4, yep, 5, 10, 16, 17, 18, 184 centimeters squared. And believe it or not, that is the end. There are so many more shapes that we can do, but I've given you the basics. I'll try and not make this video as long as it is. Thank you very much for watching. If you haven't already done so, subscribe to my YouTube channel, tell your friends, TikTok, do whatever it is you need to do. Maffsguru.com, head over there and sign up. All the videos much easier to find than they are on YouTube, but I'm going to call it a day. Hopefully see you in another video. I look forward to seeing you again. Take care. Bye-bye.